Good morning, everyone. Um, so now we would like to see the topic of uninformed searching technique from the computational intelligence. I hope you know well what is meant by uninformed searching technique. So that is uninformed means the name itself is clearly explaining you there is no information for solving the problems. Okay, so most probably searching technique is used for solving the problems. Okay, specifically artificial intelligence, the searching technique is play a major role. And here, that searching technique it is split it into two types. One is the informed searching technique and an uninformed searching technique. And the informed searching means there are some information is available for solving the problem. But uninformed searching technique means there is no informations. They have to give an problem only. We have to start from some initial state, and for an upcoming moment we try to find the next step for solving the problem. Okay, that is what on uninformed searching technique. And here we have to see that uninformed searching technique now. So I would like to explain you what is that. Yeah, so I hope you seeing this screen. Yeah, fine, thank you. Yeah, so this is an uninformed searching technique. So, uninformed searching means while searching, you have no clue whether no non goal state is better than any other. So, your searching is completely blind. Okay. So, you are having an information means it's not a blind, you have an information, but it is an uninformed. So, this is what otherwise called like a blind searching technique. Okay. So, there are various blind searching techniques are available. It's like a breadth first search, depth first search, and bidirectional searching techniques. Um, breadth first search technique is expand a shallowest unexpanded nodes. Okay, that is here it's going to extend or doing and search like level by level. Okay, it start with an root node and searching in level by level. Okay, that is this tree structure. It explaining you how to happen the breadth first search technique is. So here the A is the root node. You have to start with an A node, and we have to go that next successor as an B. Yeah, we have to move the next move into an B node. So if we are finding this is what our goal state, then we have to stop there itself. Unless otherwise, we have to move to the next node of the same level. So this birth first search is happening, the level by level search activity. So that's why this is what an birth first search. Suppose our goal state is not C means we have to move the next level and first node, that is what the D node. Suppose this is not our searching technique means that is this is not our searching, we have to move into the next node of E and the next node of F, and finally move to the final node of G. Suppose G is the goal state means we have to stop there itself and identifying we are reached the goal state. This type of technique is most probably useful for solving the 8 queen problem and 8 puzzle problem, most probably. Okay, so this is what an 8 puzzle problem. So it's a happen um, based on the BFS, that is birth first search technique way, and it's going to reach the goal state. So which is identified as goal node. Okay, so like in the above, there are different types of techniques like a depth first search and bidirectional searching techniques are available. So we have to see one by one. So there are some properties are available according to the depth technique. That is completeness, time is going to use, and space complexities and optimal are the different types of properties of the birth first search. So complete, according to the complete, yes, it always reach the goal. Okay. So according to the birth first search, it trying to find the goal state. Okay. B is the finite means. So it going to reach the goal state as such. And the time it's going to take in is the order of b power d plus 1. That is, there are d number of um, nodes are available means, so it trying to use the timing like order of b power d plus 1. So this is the number of nodes we generate for the
research techniques. Yeah. So the um, space complexity, it's like the same order of b power d plus 1. So b is the node and d plus 1 is it's like a number of nodes which is available. So it keeps every node in memory. So either in fringer or in the path to the fringe, that is the leaf node. Okay. And according to the optimal, yes, it is an optimal if we guaranteed that the deeper solutions are less optimal. Example, the step cost is equal to 1. For each step, it count the value of by 1. So the space is the bigger problem according to the birth first search, because the number of nodes get increased means automatically the number of node storage is get increased. So that is the it's like a disadvantage which is available in birth first search. So the next one is uniform cost search. Birth first is only optimal if step cost is increasing with the depth. That is example of the constant. So the uniform cost search is expand the node with the smallest path cost of g of n. So this diagram is clearly explaining you how the uniform cost search is going to happening. So according to this implementations, so the French is equal to the Q is ordered by path cost equation evaluation to the birth first if all steps cost all equal, because it is a uniform cost search. So all the path cost is equal here. All step cost is equal here. So according to the property of this particular process, the completeness is, yes, it is complete if the step cost is greater than or equal to some in sigma. So otherwise, it can get stuck in finite loops. So according to the timing of nodes with a path cost is less than or equal to the cost of optimal solutions, and the space of the nodes in path with the path cost is less than or equal to cost of the optimal solutions. And it is an optimal, yes, it is an optimal for any step cost because all the step costs are equal. The depth first search technique is another technique is coming under the uninformed searching technique. So it is process is something is different from breadth first search. It going to expand deepest unexpanded node. That is, it start with the node root node and it's going to reach the left depth end. That is left left side leaf node and it going to reach and it start with an searching activity. So according to its implementation, so the fringe is equal to lost in first out activity. Actually, we know well it is happen in the queue. So that is put successor at the front. So it start its process. It's like a, then it move to the B, then it going to expand to the E, and it's finally going to reach the H side. So all the B related nodes are so check first of all. Then if it is not available, mean then only it going to move the to the right side of the C node and further move. So its process is entirely different from BFS. That is, BFS is happen in 11 by 11, but DFS it's happened like depth by depth. It's like so when it is not going to find the goal state in C or F, then it's moved to the M, then further move. So the eight puzzle problem or 8 queen problem, it's happened like in this tree structure format. So we know well already BFS how it is happened in the 8 bustle problem. So now this is what a DFS problem based 8 bustle problem. So it going to search the goal depth by depth levels. So first one path depth is going to reach. If it is not fine, then it move to the next depth path. So it not going to search like a level by level. Instead, it going to search the node in depth by depth path level. So according to this properties of depth first search, completeness is no, it's fail in infinite depth spaces. So if the depth is large means it gets stuck, and the time it's going to taken is the order of m power m, with m is equal to maximum depth, and the space is order of p into m. So that is the linear space is going to use. So we only need to remember a single path plus expanded unexplored nodes. So if it is an optimal or not means no, it is not an optimal one. When the node depth is increased, automatically it gets stuck. So it should be having and two siblings like an techniques, depth limited search and iterative deepening search. We have to solve the problem which is available in the depth first search. That is when the depth level is increased, depth first search is get stuck. But it should be solved by using the depth limited search. So here, what the solution is going to find is we have to set some level. So we have to proceed uh, up to that particular level. If it is not, then we have to further increase the level to try to find the solution. This is what depth limited search. Here we trying to solve that infinite depth level problems. And iterative deepening search is an another like a subdivision of the depth first search. Here, if some level depth level we are not able to find the goal means we trying to extend some more the depth level, then we trying to find the goal. So this is what iterative deepening search. So this is what the depth first search techniques, which is coming under the uninformed searching technique. So this is what the proceeds of the iterative deepening search, like the limit one. So this is what the limit two. So if it is not able to find there the goal state means, again we trying to increase the next level. So level by level we are trying to increase and trying to find the goal state. So that is what iterative deepening, so the searching activity. So the next we are is trying to use the bidirectional searching activity. So under this bidirectional searching activity, so here we are start our search in both the directions. Like we have to search one direction from the root to the leaf side. Another one is leaf side to the root side. That is bottom to top and top to bottom. Like directions we are trying to find. If suppose we are going to reach some node and we are not able to find the goal means, we able to honestly say so there is no goal state in this particular tree structure. So this is what bidirectional activity. So I hope you understand what is mean by uninformed searching technique, and so what are the different types of uninformed searching techniques are available. So which are nothing but so uh, breadth first search, depth first search, and bidirectional searching techniques. So its types are like uniform cost search is coming under the breadth first search. It's going to solve the problem which is available in the breadth first search. And depth limited search and iterative deepening search, which is coming under the depth first search, is trying to solve the problem of the infinite depthing activity, which is available in the depth first search techniques. So I hope you understand this. So we will see some other topic in the next class. So thank you.